Now I will explain the NOT gate that our team member Emil built. The NOT gate has only one input and one output. It simply gives the opposite result of the input. On our breadboard, we built the NOT gate using a single in-pin transistor, a push button, a resistor, and LED. The input button is connected through a resistor to the base of the transistor. The collector is connected to the LED through another resistor, and the emitter is connected to ground. When we press the button, the transistor turns on and allows current to flow to ground, so LED turns off, output 0. When we release the button, the transistor turns off and the LED lights up, output 1. So when the input is 1, the output becomes 0. When the input is 0, the output becomes 1. This shows that the NOT gate always inverts the input signal.
Hello everyone, my name is Almasis Rafielwa, and today I will talk about how we constructed the AND gate. Basically, we started off by selecting all of the required parts for it: 3 NPN transistors, a few resistors, 2 push buttons, an LED, and some jumper wires for connections. And we had Q2 and Q3 that were our input transistors, and Q1 that acted as an output transistor and drove the LED. Each push button was connected to the base of its transistors through the resistor to control the base current. The circuit is wired so that current can pass to Q1 only when both Q2 and Q3 are switched on. The collector of Q3 connects through R4 to the base of Q1, and Q1 collector goes to the LED through R2 for protection against high current. After that, we saw how it behaved, and when no button is pressed, the LED is off, so basically no current flows. If only one button is pressed, one transistor conducts but not the other, so the LED still stays off. The LED turns on only when both buttons are pressed at the same time, because that's when Q2 and Q3 conduct together and let Q1 activate the LED. I clearly demonstrated how the AND gate proceeded, and we made it work. Thank you so much.
Hello, my name is Jamila, and today I'll explain to you how we built the NAND gate by collabing with another team, number 39. To make a NAND gate, we only use the AND gate and the NOT gate we have already built on 2 separate breadboards. Each gate already has its own LED. We take the wire from the AND gate LED and connect it to the input of the NOT gate. This way, the NOT gate flips the AND output. The LED on the NOT gate now shows the NAND output. If both buttons are pressed and the AND gate's LED lights up, but the NOT gate inverts it, so the NOT gate's LED turns off. If one or both buttons are not pressed, the AND gate's LED is off, the NOT gate inverts it, and the NOT gate's LED turns on. All other connections on both breadboards are the same. We got a working NAND by just connecting the 2 gates.
I am Amina Jafarli. In this part, I will explain how we built the OR gate. Before recording, we already placed all the main components, the transistors, resistors, and push buttons. First, we placed 3 in-pin transistors on the breadboard. The first 2 transistors, Q2 and Q3, are used as the inputs. The third one, Q1, works as the output driver that controls the LED. Then we added 2 push buttons as inputs. Resistor 1 and resistor 3, 2 kilo ohms, are connected between the input buttons and the bases of transistors Q2 and Q3 to limit base current. The collectors of Q2 and Q3 join together and connect through resistor 4, 2 kilo ohms to the base of Q1, so either input can activate it. The collector of Q1 connects to the LED through resistor 2, 330 ohms, plus 5 volts, protecting the LED from high current. Finally, we use jumper wires to connect all the necessary power and signal paths between components, connecting bases, collectors, and emitters. Then we tested that the LED stays off only when both buttons are not pressed, meaning both inputs are 0. When we press either button, the transistor turns on and activates Q1, which lights up the LED. This behavior follows the OR gate logic. The output is 1 when in output is 1. So when you see the LED light up in our video, it shows that the OR gate is working correctly.